Hello, you are Atena team from Seminar Group, a robotics group at University of São Paulo from Brazil. And here is the place that we work on our projects.
Our group is divided into several areas, among them aerial robotics, in which we seek to research and develop projects of drones and other vehicles. And one of the ways to expand our knowledge is by joining in competitions like we did last year with CopterHack. We wanted to show a little bit more of our project in the video, but in order to not make the video too long, we're going to get into deeper details in our documentation.
In this competition, we have a team made up of 6 members and a few collaborators.
Now let's talk about our project. Every day, new technologies are developed to make people's lives easier. And drones are a great example of that, working in such areas as agriculture monitoring and services. Today, one important way to the growth of the use of drones is its collaborative work, like in swarms. But there is a great complexity in swarm manipulation.
Thinking that, we decided to make a high-level interface to allow a simplified handling of a drone swarm, using of course the Clover platform, and also not requiring that the user has an advanced knowledge in ROS or other programming languages.
We'd like to align the educational and the commercial areas. We plan the creation of several tools that would allow the control of Clover swarm. And it could be used to solve problems. But while the methods are very complex, we decided to bring the ease of blocks programming to our project, and that's how Swarming Blocks was born.
We started developing the project in November by studying ROS and the Clover platform. From there, we worked in several different areas, learning a lot and trying hard to achieve our goals.
And then we finally did it.
From the Clover platform, we worked in a block programming language, adjusting the website that gives us access to the blocks platform. And here, using the developed features, we have some basic operations included, such as a launch and land. To start programming, the user can select the drone amount, the initial formation, and the mode. We developed 3 basic modes to fit the user's needs and ensure a better experience. Let's show him now.
The first one is the planning mode, which includes the Swarm Preview application, created in order to allow the user to check the drone's layout, save and load formations before starting the simulator or using real Clover. In this way, less computational power is needed and avoids possible errors during the simulation.
The second mode is the simulation mode, in which the simulation happens, indeed, using Gazebo. It allows organizing the Clovers in 2D images, such as simple geometries, letters, and roots. It's also possible to make simple 3D geometries and generate formations based on loaded figures. We can also apply some ELD effects in a swarm, all connected and in real time.
The last mode is the navigation. It allows using everything done in real Clovers. Besides this, it was also developed a control system and a first-person view to use in each drone. The biggest obstacle yet is the practical testing of this mode, because our group has no conditions to pay for a Clover swarm.
The Swarm FPV is the UI where you can easily see the camera data of a specific Clover on the swarm and control it with the keyboard. It works in real time and has the usability similar to one real control. Another important tool developed was the Swarm Checker. This node analyzes the Clover connected on the same network and publishes the IDs of the Clovers that can join the swarm. Let's take into an example to see how Swarming Blocks platform works. Let's take into Swarm Clover Blocks. I made a simple example here that I'll explain next. First, let's start our simulation. We can use our automated launch system. We can choose the number of clovers. Now we can take 3. We can take choose the launch mode. Simulation will be, and the initial formation will be 1 circle. Now we have the command here. We only have to copy, open terminal, and paste, and all the simulation environment will be started with only 1 copy and paste. Wait for that. While I explain the program, this program here will take off all the drones with this 5 meters of height. We'll set formation, change the formation from circle to line with 3 clovers and a line of 3 meters. Don't forget to apply the formation to drones really go to the formation. And we will plot the formation here with the Swarm Preview tool. I'll take the 3D plot. Next, we will animate the formation, taking to 1 loop that rotate the formation in X and in Z, and apply and wait for 0.5 seconds. It will take a good effect for us. To run it, it's only needed to click here, and you can see the simulation before. It has 3 clovers on circle formation, and we can send the program. They will take off. The Swarm Preview will appear when they change their formation. Changes to line. Okay, it's line. I resume. Then they will start the animation. You can see here the animation. It's rotating in X and in Z. With this method, we can apply the same algorithm to complex formation and get really good animations, as we can see now.
For us, the work isn't done yet, as we have a lot of new ideas to implement in our project, in order to bring new tools and functionalities to it. We also want to keep improving the project, the interface, and the beauty functions. Among the features that we pretend to make in the future, we can mention, for example, the optimization of the operations involving the computer vision and the collision avoidance system. We also want to make means that the drones can work independently at specific tasks. But we don't want to keep working just in the simulated world, but also in the real one, in the physical one, with real clovers and testing them. Another of our goals is to teach anyone how to control a swarm of drones. allowing that even a programmation beginner to control them, and arousing each time more the interest for robotics and engineering.
COEX is a company that can help us a lot in the goals we have, with significant contributions in the technical commercial side and with the knowledge and expertise to make possible our inherent advances. But also, with the company initiatives focused on the education side to an effort for swarming blocks to affect more and more people, reaching schools and social projects allowing that even children can control and operate our project.